Hi, this video is to show how to get a 3D model from Tinkercad to Cura slicing software for 3D printing. So when you're done with your model, you're modeling in Tinkercad, you simply export. You can, in this case, there's only one solid object in the model, so it's going to be everything in the design. You can also, if you have more than one object, notice that we clicked STL. STL is just a solid object file, and we see it here in our downloads. Now, Chromebooks cannot run the slicer software Cura. I'm going to type Cura in here. So you're going to need to get your downloaded file to the slicer software. You can do that by opening Tinkercad on a classroom PC that has Cura, and then downloading to that PC to bring it into Cura. You can also download the Tinkercad STL file on your Chromebook and email it to yourself, and then pull up your email on the classroom PC and bring it into Cura. Now, I'm waiting here. I don't see Cura opening, so I'm just going to try again. I may have missed something there. Oh, and here it is. So this Cura is 3D slicing software, and what it allows you to do is tell, it develops something called G-code that allows you to, that tells the printer exactly how to print. So the way that we get our file in here is to go to that envelope, double click on the base. You see I've already downloaded the other files from Tinkercad also. So I'm just going to grab the forearm. If it's not all the way on the bed, it will show up like so, but look like a solid object when it's on the print bed. Okay, the upper arm, we'll need two of the upper arm. So we're going to go to multiply objects, make one copy. All right, now just a couple of quick things. It really helps to use a mouse when navigating around Cura. I can move objects, multiply them as you've seen. I can change scale, which of course I don't want to do in this application. But I just want to rotate this 90 degrees to talk about how the 3D printer prints and something called infill. Okay, the 3D printer, this is red because this cannot be printed without support. The printer cannot print in outer space. I always like to check my model in layer view. In layer view, you see what shows up here is the infill. Right here, this is infill that you would have to break out later if you printed this way. Now, also in layer view, you can actually see exactly how the print head is going to print, just for fun mostly. Okay, you can see how each layer will print. But it's really critical to check the base layers, okay, and make sure that they are flat on the print bed. Now, I rotated this object mostly just to show that we don't want, if we can avoid it, we'd rather not print all that infill. It's more material that we just have to break out and throw away. So I'll go back to the way this was originally oriented, and you'll see oriented this way, there's just no need to print infill anywhere. I always like to avoid printing support, rather. I'm using the wrong term. I like to avoid printing support if I don't have to. Infill, I've been using incorrectly. Infill actually refers to how much of this is hollow. You almost never print a 3D print solid because it warps. It's too much hot material, and it's not necessary for strength. So there, everything looks good in layer view. You see the difference. Solid view just makes it look more like a solid object. So before printing, we need to go ahead and change the material. The material settings determine things like the print temperature, which is super critical. Printing too hot will cause warping and things won't stick to the print bed. So different plastic materials require different settings. And we always use PLA Village Plastic with the Hatchbox PLA that we have. It's not Village Plastic PLA, but the settings work as well. You can print high speed. That usually comes out pretty well. I generally print standard. I almost never print high detail. That will double the print time necessary. So this is critical. A couple other things. You always want to make sure that you're set for the Lulzbot Taz 6. The material is probably the second biggest cause of a print fail. Okay, the last step is to save to a removable SD card so this file can be brought over to the printer. Okay, so the final step here, you're going to see when I insert the SD card from the printer, this save to file, it's going to, I'm just going to close this, save to removable drive. So it's recognizing the SD card. I just click save. Tells me I'm ready to eject and bring that over to the printer. Before we end here, I just want to point out some other information available in Kira. It estimates this print is going to take about 6 hours and 46 minutes. It's going to take about 12 meters of material and 99 grams of PLA. PLA cost about 1 cent per gram, so just to put that into perspective, this is about a $1 print. It's already saved. We're ready to move that over to the printer.